First, let's look at it graphically. Okay. Graphically, we have this notation. I have this graph, as you can see there. It is a piecewise graph. It has some broken pieces and things like that, and that's gonna play a role in me evaluating certain things here. A lot of people think that, when I say the limit of f of x as x approaches 4, which is how I would actually read a, and f of 4, they're the same thing. And there's a reason why they believe that, because one of the first things that we usually do assume, is if we're evaluating the limit of a function, is we let x be the number I'm approaching and see what I get. That doesn't always work though. In a graphical standpoint, it means, okay, if I'm approaching 4 as an x value, if I'm following the graph and approaching 4, from the left hand side I'm approaching this way, from the right hand side I'm approaching this way, I can see that the graphs are both approaching the y value of 5, which is why I would say that the limit of f of x as x approaches 4 is 5. And if I actually evaluate f of 4, well, f of 4 is right here, this point right here, which I see is also 5. That happens a lot, especially in graphs that are continuous. And one of the things that you will discuss at length in calculus initially when you talk about limits is continuity, whether or not a function is continuous at a given point. When I look at the limit of f of x as x approaches 1, now if I approach from the left hand side, I'm approaching this point right here where that open circle is. Same thing if I'm approaching from the right hand side, if I'm following the graph. So the limit is, as x approaches 1 is actually 2. But what is f of 1? Well, because I have a closed dot right here, when x equals 1, and that's at the y value 3, I would say that f of 1 would equal 3. Notice that the graph does have a hole here. Sometimes when you have a hole, you won't necessarily have a point, that where the function assumes a value for that x value. You just may have a hole. This is a discontinuity, though. I mean, when I draw the graph as I approach 1, in order for me to put that dot out there, I do have to lift my pencil off of the paper to draw it. Just like whenever I deal with the situation as x approaches -5, there's a clear-cut break there. There's no way I could draw that without having to, again, lift my pencil off the paper or lift my, light pen off of my computer screen just in order to make that break, hold up. So, but when I look at, some additional notation, notice, it might be harder to see here because it usually is pretty small. Right here, on that in part E, it says limit as x approaches -5. I have this little plus sign where the exponent normally would be. That notation means I'm approaching x being -5 from the right hand side. That means I'm looking at it. When I look at it, it means I'm approaching from this direction here. And as I draw closer and closer to -5, following f of x, the y value approaches -4, which is why that answer is -4. When I approach now the f, same kind of thing, except now where that exponent would normally be, I have a minus sign. That means I'm approaching from the negative side or the left side. So if I'm approaching from the left, as you see on the graph, my graph is approaching that open dot up there, which means it's approaching a y value of 6. So whenever I'm discussing just a limit approaching from one side only, I'm going to see those little pluses and minuses in the exponent position to kind of indicate that. If I don't see that, I'm assuming that I'm approaching x from both sides, either from the left and the right. In this case here, when I approach from the right and I approach from the left, I get two totally different values. When that happens, I could say that the limit does not exist. And anytime you have a limit not existing, that usually indicates a discontinuity, or in most cases a break in the graph, some sort of break. F of negative 5, well, again, I would evaluate that by saying, well, the closed dot's at negative 5, at the y value negative 4, so f of negative 5 is negative 4. Another thing you'll discuss when you start talking about continuity of a function, if it is discontinuous, which, it is discontinuous at negative 5, but you would also say it's continuous from the right, mostly because, approaching from the right and the value of f of the function of negative as x approaches negative x being negative 5 are the same thing. But that's something that's going to be talked about much more in calculus. I just wanted to give you an idea of how to, if you have the graph, how to more or less evaluate a limit and what a left-hand and right-hand limit are and how they're demonstrated.